So, base. If I look at this y equals a times b to the x, the base is in the position that gets the exponent. A is the leading coefficient, so I'm not going to pick a number in the leading coefficient position. B is the base. We have to recognize the base because that's the difference between growth from yesterday and then decay today. You've got to recognize what's in the B position. So, 1/2 for the first one, 5 for the next one, -2. Those are the bases. So if you wanted to put B by every one of those. Let's talk about domain and range. First off, one of the characteristics about domain with something exponential, which fits both of these, domain is always all real numbers for exponential functions. That does not change. I can plug in any number in these problems. It's the range that's going to be a little difficult. Range. There are only two options. I'm either writing this, y being bigger than 0, either the outputs are all going to be positive or all the outputs are going to be negative. It depends on the leading coefficient. If the leading coefficient's positive, then the outputs will be positive. If the leading coefficient's negative, outputs will be negative. So, in the first case, leading coefficient is +5, so all the outputs will be positive. In the second case, however, because the leading coefficient is a -1/4, the outputs will all be negative. So first off, exponential decay functions. Exponential decay functions have the same form as yesterday, where you have a times b to a power. Sometimes this power may have some type of shift with it, or we might have a -1 outside. But either way, you have a coefficient and you have a base raised to a power. Now, the leading coefficient's not always positive. I should delete this. But the base, we need to underline this. For decay functions, in order to be decay, the base is between 0 and 1. When we say state whether the function is an exponential growth or decay function, I'm really paying attention to that base. Yesterday, all the bases were bigger than 1. Today, now we're going to see, okay, when is the base between 0 and 1? So you've got to pick out the bases in each example. So first one's decay. So this base is written like a fraction, but it's bigger than 1, so it's actually growth. Check that on homework. Be careful on that. Not all fractions are going to be decay. So let's talk about this. It needs to be b to a positive x. It's not the 2. It's actually 2 to the -1 power. If I look at this as 2 to a -1 power, then I'll just have an x left as the exponent. But 2 to the -1 power does not mean that this is -2. You've got to realize 2 to the -1 power makes it a reciprocal. It's actually 1/2. Make a mental note of this. If you see a -x as an exponent, that means you're going to have to flip your base. It may change a growth to a decay or a decay to growth just by flipping that. We're going to graph the following function. So notice the base. The base is 1/3, which is in between 0 and 1. We're going to see what a decay function looks like. This is in a really nice form because I'm not having a shift in the exponent, or I don't have a vertical shift out here. So plugging in numbers will be nice. We talked about how these functions are going to start spitting out asymptotes. So this -10, when I plug it in, will help me find the asymptote. So when we plugged in -10, we got a really negative number. Wait a second. Yesterday during during warm-up, if you plugged in a number and you got really more negative, we've got an arrow on this end pointing way down. So maybe it's not -10 that I want to plug in. I'm going to add +10 on the end. So we get the following. So when we plugged in negative 10 like yesterday, wait a second, we got something really, really negative. So with these exponential decay problems, are going to have a different ending arrow with the asymptote. Let's graph the point. So we're exploring. Negative 1 got me negative 6. Okay, that fits on my graph. That way I at least have something. And I think the rest may be off my grid. But if I connect the points, I get a situation like this. Let's talk about domain. Domain is actually the same as yesterday. So domain's all real numbers, and because the leading coefficient's negative, range is less than 0. Notice the asymptote. The asymptote is still the x-axis, or y equals 0. We just have the right arrow going to it. So if I was going to talk about end behavior, as x goes to negative infinity, the left arrow is also going negative infinity. But the right arrow is not going up or down, it's sloping off. So as we go to the right, the outputs are approaching 0.